Welcome back, everyone. In today's episode, I'm going to be moving on to the sliding window category. Last episode, I tackled the binary search problem, and that one went pretty well. Since it was the last easy problem in the section, I'm already going to move on to the next one. So yeah, that's sliding window, and if you've seen all the videos in the series so far, I think I've actually talked about and even used the sliding window technique a few times already, so hopefully I'll be able to figure this one out. Again, I've never seen any of these problems before. I'm doing them all sight unseen for the first time. So if I struggle, you get to watch. If I do well, then we celebrate together. So it looks like today's is called Best Time to Buy and Sell Stock, and again, only easy problem in this category. So let's go ahead and see what this one looks like. Right, so you are given an array prices where prices I is the price of a given stock on the ith day. Okay, you want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return 0. Okay, let's take a look at a few examples because I'm not entirely clear yet what it means. So if these are the prices of the stock, output is 5. So we can buy on day 2, which is here, and sell on day 5, which is here, right? Yeah, so 6 minus 1 is 5. And I was just going to say this. So the way you would think to do this is to just find the minimum and the maximum value in the array and just subtract them. But you can't do that here because you can't buy on day 2 and then sell on the first day. That's not allowed. Okay, so that makes sense. And then here, if you notice, every value in this array is decreasing. Every value is strictly less than its previous value. So you can't possibly make a profit because no matter when you buy it, you'll always be selling it for a loss. So 0 is kind of like don't buy anything. And then our constraints, the length of the prices can be pretty big. The value of the prices can be pretty big as well. I don't think any of those dictate too much. Right. So I don't have a solution yet in mind, so let's pop down to the whiteboard and think about what we might do. Right. So in previous episodes, I looked at the sliding window technique, and we'll see how that plays out in this problem, but let me write out the example. And I think the idea that's coming to mind immediately is that we kind of need to process every element and look and see what the maximum is that we could get. So what I mean by that is, if we buy at 7, so I'll put a B there. If we sell at 1, we make minus 6. If we sell at 5, we make minus 2. If we sell at 3, we make minus 4, minus 1, minus 3. And then we could keep track of all of those values. If we buy at 1, we can sell at any of these 4, and we would make 4, 2, 5, and 3. If we buy at 5, we could make minus 2, plus 1, or minus 1. If we buy at 3, we could make 3 if we sold at 6, or 1 if we sold at 4, and finally, if we buy at 6, we can make -2. So in this listing of values here, there is a maximum, which is 5. And so if we just keep track of the values for every possible buy-sell pair, and at the end we could just return the maximum one. What I'm wondering is if there's any trick to not have to check every value. And so what I mean is, say we've come to know that there is a 5, that this is the max value we've seen so far. So this is a good start, and I definitely think it'll work. But obviously this is going to be a bit slow, because if the array is tens of thousands of stock prices long, then this is going to take a really long time to iterate through. So I might go and code this solution up, but let's just think real quick about if there's a better way. And we haven't really used the sliding window at all, right? Because the sliding window technique is where you have, let me draw this in another color, is where you have some sort of window. And that window might look at 3 values at a time, but then you can move it and look at other values at a time. And this is a popular technique for a lot of algorithmic questions that involve arrays, and the window can increase or decrease in size. And I haven't seemed to use it at all. So maybe I'm missing something here. So let's think for a moment. Again, I'm wondering if I can find a way to skip some of these rows as we go, so there's not as much to calculate. Like maybe, for instance, going back to the problem, this example is interesting, right? Because using the technique I talked about up here, what I would end up doing here is keeping track of 7, starting at 7. My possible values for the first one would be -1, -3, -4, -6, so on and so forth. But I don't need to be checking all of these when it's less than the previous value. So maybe what I really need to do is keep track of a min, which I set at 7. And if any of the numbers we see after it are less than that, then we can skip processing the 7 and just go straight to the 6. And then if this next one is less than that, we just go straight to the 4. And then if the next one's less than that, we go straight to the 3, straight to the 1, and then we're at the end and we never found anything. That's an interesting idea, because then back to our other example that was like 7, 1. What was it exactly? 7, 1, 5, 3, 6, 4. In this case, our min is 7. Then we immediately find something less than 7, which is 1. So we can start at the 1. And then as we start processing through, we see a 5. Well, that's interesting because that's bigger. So we make +4. Then we move on to the 3. That's still bigger than our min. So then we get a 2, then a 5, then a 3. And then the question is, are we done then? In this case, we are. But I imagine we'd want to keep flicking through the array, looking like this. And then if we see something that was smaller than 1, so for instance, if we then saw a 0, once we hit the 0, we would want to replace the min with the 0 because now we have a chance to make something higher. So basically, I think this is where the window comes in. We create a window around a value, and then we start expanding that window. But as soon as we come to something smaller than our min, we get rid of that window and open up a new one. And we grow that one for as long as we can, keeping track of all of the values that we get, and specifically noting the largest. And then when we see another smaller value, we get rid of the window we had and start a new one. This might be the way to do it. Yeah, let's give this a try because I think it'll be a little bit faster than my first solution. And if this doesn't work, I'll go back to my first solution, but let's flip back to the code. So in this case, we will have a min value, which we will set equal to, let's just say, the first value in prices. And then we'll loop through each price in the prices array. And the first thing we're going to want to do, like I talked about on the whiteboard there, is we're going to want to see if the value we come to next is less than the value that we're currently at, basically. So basically, do we want to update this min value or not? So once I've processed this first one, I guess I can start, here, why don't I do this? Because this is an iterable, we know we can add our index to it. I explained this in a previous video. But if index is 0, we'll just do it like this. Equals price. We can set that equal to 0 or something, it doesn't matter. So if the index is 0, we set the min val equal to whatever current price we're at. In any other case, so after the first index, what we want to do is say if price is less than the min value, we want to set the min value equal to the price. So in this case, we would set the min value to 1. We could continue. We also want to keep track of max profit, because this is what we're eventually going to return. Why don't I call this, instead of that, min by price. Min value. Right. So the minimum buying price we set initially to the first price. So in this case, we'd set it to 7. Then every time we check if the price we're currently at is less than that. If it's less than that, we update the min buy price to be whatever we're on, in this case 1. And then we have to also keep track of current max profit. We also have to reset our current max profit. And then we continue. What I'm thinking is, as we expand that window, we'll keep track of whatever the max profit we've seen is here. But then when we find a place that we need to change, we need to reset the min buy price, reset the max profit, and then say that the max profit equals the max of the current max profit like this. Hopefully that makes sense. So every time we encounter a new value that's smaller, we need to take whatever, we need to reset the profits we were keeping track of in the current window. And then we need to set the max overall profit is the largest value between whatever it currently is and what we saw in that last window. Right, so if the price is not less than the min buy price, so it's greater than or equal to it, then what do we want to do? We want to calculate the current profit, which is going to be the sell price so it's going to be the all right, let me think about this again. So we set it to 7, then we come in the next time into our else. The price is less than the min buy price, so we reset everything. And then we go back up, we iterate to the next one. So now we're on 5. Index is not 0, so we fall down here. Price is not less than the buy price, so now we're down here. And we say current profit equals min. It's basically price, which is the 5 that we're on, minus the min buy price, which would be 5 minus 1. Like that. And what we have to do is say current max profit equals the max of whatever it currently is and the current profit that we just calculated. Can I make this any bigger? Yeah, that's fine for now. And then, now that we have this, would it be crazy to think this might work? Because then at the end, all we do is return max profit. Let's see. Right. Whoops. Okay, so case 2 worked. Case 1 did not. Returned 0, expected 5. So let's see why, shall we? So we set the min buy price equal to the current price, which means we set the min buy price at 7 to start. On the next iteration, 1 is less than 5, or 1 is less than 7, so we set the min buy price equal to the price. So we set this to 1. We reset this to 0, which is what it was at already. And the max profit is the maximum of 0 and 0. Aha. I think I need to set this after. That's not going to fix it, is it? I don't think so. Yeah, not quite. But then the max profit is the max between whatever it currently is in this, which at this point is all 0. We reset everything. Next one is a 5, so this doesn't happen, this doesn't happen, that doesn't happen. So we're down here. So the current profit is the price we're at, which is 5, minus the min buy price, which is 1. That means we get 4. So the current max profit equals the max of whatever it is now, which should be 0, whatever we just calculated, which should be 4. So this should end up being 4. Then we loop again. It's 3. We come down here, we calculate 3 minus 1, which is 2, so we set the max, it's the max of 4 and 2, so it should stay 4. The next one should set it to 5, this one should set it to 4. Ah, I see. So what I could do instead is just say, instead of doing this up here, I could just do, we can just keep track of the max profit the whole time. Like that. Let's see if that works. Cool, let's try submitting. Right on. So that's, I'm glad that worked. I noticed about the 50th percentile runtime and really terribly using memory, which is kind of interesting. I use these variables here. I didn't really use a whole lot of memory other than some of these variables, so that's interesting. So clearly this is not the best solution of all time, but it did work. And for that reason I'm happy. So let's go back to here and check that off. And that was the last easy problem. So I've completed 7 total problems now, and looks like I'll be heading into the linked list category next. So stay tuned for that video, and thanks so much for watching.